All right, so in this lesson, this is the first video that I'm going to show you guys today. This is for Wednesday, September 9th for AP Chemistry. Today we're going to go over the last little bit in Chapter 2, which is on bonding and naming compounds. So covalent bonding, ionic bonding, and how to name compounds, how to name chemicals. We're going to do a video on face-to-face expectations. That will be in a different video than this one. Okay, so we'll watch that video, and then you will complete a Google form over that. Okay, we're going to go over problem set number 2, which is the AP multiple choice questions from chapter 1. I had a student or two that was requesting me to go over that, so I'll do another video where I go over that. All right, so there's going to be 3 videos. This is the first one. This is where we're going to finish chapter 2. Another video is going to be on face-to-face expectations. And then the third video is going to be me going over problem set number 2, discussing how to approach chapter 2 problem set, which I'm assigning today, and then how to complete the NIMSY notes, just as a reminder. All right? I know that's a lot. So this next slide is for virtual students. Virtual students will need to watch this video first, and then we're going to return to the Google Meets after you're done. I'm just going to give you guys the link to the video, and then you need to watch it on your own device. I'm not going to present it through class, because during class I'm going to be showing my face-to-face kids a different video. So we'll be doing the same things, just in a different order. Okay, so we'll first watch this video over chapter 2, and then we're going to return to the Google Meets link for a discussion, and I'll take attendance at that point as well. After we're done with this, we're going to watch a video discussing the homework and the NIMSY notes. And then at the end of class, you can return to the Google Meets and ask any last questions that you have. All right. Our class is extra long, so if you get this done early, then you can go if you're virtual. Okay. And then the last thing I need you to do is to watch the video over the expectations and complete the Google form over expectations. So for my virtual learners, this will be for homework. I figure I'd rather let you do this for homework, since you're not doing face-to-face. But I still will need all students to complete the Google form over expectations for face-to-face learning, so that if you do switch to face-to-face learning, you know what's expected when you come. Okay. Which I still highly recommend that you stay virtual if possible. What do face-to-face students need to do? All right, face-to-face students will be watching the video over expectations first. I need them to watch the expectations for entering the classroom, keeping their masks on, all that kind of stuff. So they will watch that video first. They'll complete the Google form after that, and then they will watch this video over chapter 2, and so on. Okay. All right, so here's our assignments. Remember that students are required to participate in the discussion during class. So we'll have a discussion in class where I ask you guys specific questions over the content that we're going to go over in just a moment, and kind of see if you're getting it. Okay, so I'll assign each student that's virtual or face-to-face. Each student will have a problem, and you'll need to solve that problem. Okay, and if you need my help, I'm happy helping. All right, we're learning. So if you don't understand it, then then I'll jump in and help. Then I'll talk about, let's see. So yeah, make sure that you guys are completing your assignments in class. And then chapter 2 problem set I posted recently, and it's due Wednesday the 18th. That's next Wednesday. I'll give you a full week to do that. Then the NIMSY notes, chapter 3, I posted. They're going to be due next Sunday on the 20th. Not this Sunday, but next Sunday. So you've got a full week and a half for those, because they're kind of long. Okay. All right, let's talk about bonding. So we've been talking about chapter 2, which is on atoms, molecules, and ions. There are several kinds of bonds that can be formed between atoms. The 2 main ones that you should know about, whether it be what you learned in honors chemistry or chemistry that you've already had, or what you learned in AP chemistry. But there's 2 kinds of bonds that you should be familiar with. One of them is covalent bonds, and then the other is ionic bonds. And then maybe you'll see metallic bonds, but I'll talk about all 3 of them in this video. So covalent bonds are formed when atoms share electrons. And so what happens is 2 atoms want to have an octet. They want to fill their outer shell, and so they want to obtain that octet, which the rule of 8. The octet is the fact that all atoms react and combine to form molecules or compounds so that they fill their outer shell. And so when atoms do this, they may share electrons. An example is hydrogen. So hydrogen has one electron in its outer shell, okay, and it wants to have a full outer shell, which would mean it would need 2 electrons. So what each hydrogen atom will do with his 1 electron is he will go and find another hydrogen atom to pair with, right? And it's kind of romantic, right? They both want electrons, so they share them. So these 2 hydrogens will get together and share electrons, okay? The chemical formulas of molecules can be shown in different ways. We can write it as H2O, or maybe we could draw a picture of it, right? So 2 hydrogens for 1 oxygens. The lines between the bonds, these are the lines that we're going to show. A solid line like this represents a covalent bond where atoms are shared. So 2 covalent bonds, each between a hydrogen and an oxygen. So that's where hydrogen and oxygen are sharing electrons. And then these dots are lone pair electrons. These exist on oxygen only. They are oxygen's pairs of electrons, 2 pairs of electrons. And these belong on the oxygen, and they do not belong on the hydrogen. So oxygen owns them. All right, if you count them, 1, 2, 3, 4. Okay, that's 4 electrons on oxygen only. And then each bond is 2 electrons. So that's 2 more, which would give us 6. That's 2 more, which would give us 8. Oxygen wants 8 in its outer shell. All atoms want 8 in their outer shell. Okay, 8 for oxygen, 8 for a lot of elements, and then 2 for hydrogen. Hydrogen's kind of weird. He's a smaller atom, and so his outer shell can only hold 2 electrons, and so he wants 2. So if hydrogen is bonded to an oxygen, 2 electrons are shared in that bond. Okay, and I can even draw this. So what I do a lot on these Lewis dot structures is I'll draw an electron there and there and there and there. Now let's count. 1, 2, 3, 4, 5, 6, 7, 8. So now you can see that there are 8 electrons on oxygen. Oxygen's happy. And then look at hydrogen. 2 electrons that he's got are shared. That's 2 on hydrogen. He's happy. He wants 2 in his outer shell. And then this hydrogen is happy. And so we should be able to look at Lewis dot diagrams and tell if they're correct. We should be able to draw them from scratch for just about any molecule that's pretty common. Ammonia, methane. So we'll practice Lewis structures. And there's a whole chapter that we'll do at the end of the course on bonding. Okay, so kind of near the AP test, we'll do kind of advanced topics on bonding. But now we want to talk about bonding so that when we talk about reactions and molecules, we know what the bonds are between them. Okay. Now, ions are formed when electrons are lost or gained, and we talked about that recently. And you guys should know a lot about ions. There's 2 types of ions that form. There's cations, which remember if you write as like this with the plus sign, then you know that they're positive. So replace the T with the plus sign. Or remember that cats are positively adorable, right? Maybe you agree. I think cats are adorable. So I remember that cations are positive because they're positively adorable. Get it? Cations are positive, and they result when an atom loses electrons, right? If an atom like sodium loses an electron, it becomes a sodium ion with a plus charge and a lone electron that is now separated from the atom. So the atom was first neutral. If you take away an electron, which is negatively charged, then the ion it forms is now positive. So cations lose electrons. This is what metals like to do. Metals like to lose electrons. Okay. Hey, look, there's the same thing I just wrote. That's funny. Anions are negative. Okay. And like I said, if you can remember that cations are positive, then just remember that anions are the opposite. They're negative. And this is when it gains an electron. Okay, the reason that they become negative when they gain electrons is because electrons are negatively charged. So take a neutral atom and give it an extra electron, and boom, it makes a negative charge. This is what nonmetals do. Okay, and so nonmetals are opposite of metals. Metals like to lose electrons. This is why they are shiny. This is why they are durable. They're usually kind of malleable. You can bend them. Right, they're shiny. And then nonmetals are usually brittle. meaning that if you smash it or apply force to it, it will shatter. So nonmetals are a little bit more brittle. They're not usually shiny. They're usually gas. And so this fact that they gain electrons is why they have those properties, and that's why they're opposites. Okay. All right. How do you form an ionic bond? All right, we can call it an electrostatic or Coulombic attraction between oppositely charged ions. So if I have sodium ion, the +1, and a chlorine atom, which is what this is showing here, these are sodium atoms and these are chlorine atoms. They're going to attract each other. Opposites attract. And so they're going to kind of form a little bond there. That's called an ionic bond, and it's called ionic because they're both ions. And so opposite charges attract. Kind of like opposite poles of a magnet attract, right? The north pole of one magnet will attract the south pole of another magnet, right? So opposite poles will attract each other. So it's kind of the same thing, but with charges. So we call that Coulombic or electrostatic attraction, and the bonding is called ionic bonding. This occurs between a metal and a nonmetal. Okay, covalent bonding that we talked about a minute ago is between two nonmetals. Two nonmetals that are both wanting to gain more electrons to fill their outer shells will share electrons. Okay, but in this case, we've got a metal and a nonmetal, a positive and a negative. The metals are usually positive, nonmetals are usually negative. Okay, assume that two elements, A and B, form a molecular compound with the formula A2B, and two other elements, C and D, form an ionic compound with the formula CD. Draw a molecular view of each compound using the following symbols. Draw at least two formula units for each. So I'll let you guys do this in class, okay? Let's see. Here's our periodic table. Let's first show the metals from the nonmetals. So these are metals, okay? I'm going to circle the metals. These are our metals. I'm going to count aluminum as a metal, okay? And I'm going to count these of all metals. So these are our metals. It also continues down here. These are all metals. So as you can see, all of those are metals. So let's shade them. Oh my gosh. I think this is what, 60% of the periodic table? Maybe even 70%. 70% of the periodic table is metals. All of that, metals. Okay, they like to lose electrons and become positive charge. So they like to perform cations. These guys up here, let's do a different color, are nonmetals. Okay, here's our nonmetals. They just form this little corner of the periodic table, and don't forget about Mr. Hydrogen. He's a nonmetal too. So these are nonmetals. They like to gain electrons. They have a tendency to pull electrons to themselves and make covalent compounds, so they share electrons. And they're very electronegative, which means that they like to pull electrons to themselves. Okay, metals are electropositive. They like to lose electrons. Okay. All right, the metals are on the left side, nonmetals are on the right side. There are lots of groups here, okay? So let's look at each group. The first group, lithium down to francium, are called the alkali metals. They form +1 ions. They're very reactive, explosive actually if you put them in water. So these are the most reactive metals. And actually the very most reactive metal that exists is francium, which is actually radioactive, so it's not very common, but francium is the most reactive metal. And then it kind of decreases down, and then it decreases that way, the reactivity of the metals. The next group is the alkaline earth metals. They're pretty reactive, but a little less so. So this would be group 2. They form +2 ions. And like I said, they're pretty reactive, but not as much. These guys in the middle are called the transition metals, and that's because they have many transition states where they can have different states. So titanium, when it forms ions, it could have a +2 or it could have a +4. And so many transition states are possible, and chemical conditions will determine which state is going to occur. Another example is iron. Iron is a +2 or a +4. And that depends on whether it's in the presence or with oxygen or not. Okay, so metals where these metals can transition between charges. Now there are some in here that only have one charge, and we do need to memorize them. Okay, one of them is silver. Silver is always a +1. It's in this row, it's in this group where there's many charges possible, but it does not change charge. It is always a +1. Zinc is a +2. It's always a +2. It has no other charge that it forms. And then aluminum is a +3. And the way that I like to memorize that myself personally is this is a +3, and then go down a step, go diagonal, +2, +1. So those three we need to memorize, okay? Then we need to know the charges of these guys too. So anything in group 1 is +1, anything in group 2 is +2, silver is +1, zinc's +2, aluminum's +3, okay? Most of these guys in this group will form a +3. They can also do a -3, but it's kind of usually a +3. So let's say plus or minus 3. These guys are a plus or minus 4 because they got 4 electrons in their outer shell, so they can gain 4 or lose 4. These guys in this row, the nitrogen family, usually have a -3. So these guys are usually a -3. These guys, like oxygen, are a -2, and you need to memorize oxygen. Oxygen has a -2 charge, nothing else. So it's kind of rare. There's possible other charges, but pretty much oxygen's -2. Okay, and we'll hit that at some point. But for now, let's just say oxygen's -2. Everything in this group's -2. Everything in this group's -1. And then these are the noble gases, so they don't make ions, so 0. No charges for those guys. They don't like to share their electrons. I forgot to mention the metalloids. These are metalloids. The metalloids are the ones that are on this stair step, so I just kind of circled them. So these are the metalloids here. And they have properties of the metals and the nonmetals, so they're kind of in between. Okay, let's talk about naming compounds. It does say that you need to memorize some tables here. Okay. It's extremely important that you have memorized the names and symbols of common ions. You are expected to know them pretty quickly, and we're going to be doing so much with these formulas that you really need to have a good foundation in naming compounds, okay, and knowing these ions. All right, so there's some compounds that are called binary molecular compounds, and there's when you have two different nonmetals. Okay, so if you have two different nonmetals and they form a covalent bond, we call that a molecular compound. A molecule is just two nonmetals together. So water would be an example. Hydrogen would be an example. Oxygen would be an example. Carbon monoxide, carbon dioxide. So these are two nonmetals sharing electrons. We name the first element using its prefix, and we have to indicate how many of that atom is in the molecule in the first one. Oh, I'm sorry, we don't. Okay, so like this one, if we say this one, this is carbon monoxide. Notice I just said carbon. I don't have to say monocarbon. I don't have to indicate 1, right? If we say carbon, we mean 1, unless we put a prefix in front, and then it would be 2. Like this one down here, it's got 2 nitrogens. We would say dinitrogen, okay? But in this case, we just say the first element and use a prefix if needed, which if there's 1, we don't need it. So carbon monoxide, CO, that's just 1 carbon, 1 oxygen. All right, and then we name the second element, and it has to always use a prefix for the second one. So notice when I say carbon monoxide, I say carbon, and that just means 1 carbon. I don't have to say mono. And then I say monoxide, right? Mono meaning 1. You have to indicate how many of the second element are present. All right, so how would we name water? Dihydrogen monoxide. Dihydrogen monoxide. And I've actually made some jokes with students where I accidentally, I pretended like I poured some dihydrogen monoxide on my hand and it was burning and kind of flipped out. And I was like, guys, I got dihydrogen monoxide on my hands, and they kind of flipped out. And then I was like, actually, it's just water. Get it? Dihydrogen monoxide. Yeah. This is called hydrogen or dihydrogen. This is called oxygen or dioxygen. This is carbon monoxide. This is dinitrogen pentoxide. Okay, di means 2, penta means 5. Okay, let's go through the prefixes. Mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, I think it's hepta is 7, octa is 8, nona is 9, and deca is 10. So this is our numbers for our prefixes for molecular compounds, covalent compounds. Ionic compounds consist of a metal and a nonmetal. And what we do is we name the metal first, the cation first, and then we have the nonmetal next. But then we always change the name to IDE. So think of it, sodium chloride. I name the first element the metal. I don't change the name at all. I just write sodium from the periodic table, and then I put chloride. So that's chlorine where the ending is changed to ide. And that's how I name that guy. You never indicate the numbers. Okay, so I would not say monosodium monochloride. I would not call it sodium monochloride, just sodium chloride. The reason that we do not need to indicate the numbers is because we can tell the formula and the numbers of each ion by charge balanced. Okay, I know that sodium's a +1 from the periodic table because it's in group 1, and then I know that chlorine is a -1 because it's in group 7 with the halogens, group 7. Let's write that. I don't think I mentioned that. Group 7 halogens. These are very toxic nonmetals. They're the most reactive nonmetals, and they're mostly gases. And then if you don't know, group 8 is the noble gases. And they don't make compounds. They don't react. Noble gases. That's why we call them noble. They're too good to react with anybody else. Okay. When writing formulas for ionic compounds, the positive and negatives must be equal. Okay. And then when naming compounds, if you have a transition metal, then you need to indicate the Roman numeral for the charge. So if I wanted to say iron, let's say iron chloride. Okay, and I'm gonna put parentheses there, and we'll fill that in. So iron chloride. Let's say it's the iron chloride. Okay, I got iron, and I know it's a positive, and then I got chlorine, which is a minus, and it's a -1 because it's in group 7. And so I know that my net negative charge is a -2. So if I have one iron atom, and I know that these two need to balance, then I know that that iron is a +2. So what we need to do when we write the formula and look at a formula, we need to be able to determine what the charge is on that transition metal. Okay, so in this case, we determined that it's a +2 because it must balance with a -2. So that's charge balance. All right, and so the way that we write or show that the iron is a +2 is we write Roman numeral 2. All right, so over here, let's write the Roman numerals. This is Roman numeral 1 for a +1. If it's a +2, then we write 2. If it's a +3, we write a 3. If you guys don't know your Roman numerals, +4, which we don't use them that much, so I don't blame you. That's 4. +5 is a V with the lines, and then +6 is a VI. +7 is a VII. +8 is a VIII. +9 is a IX, I believe, and then a +10 is X. Okay, and usually we don't get beyond +5. So what we would do is we would write, if we had an iron, say we had an iron with a +5, which isn't possible. Let's pretend like it was. Then I would write iron 5, and I would put a V there, right? So I put the V there. Iron 5, and then I would write the rest of the name of the compound. So to name ionic compounds, we put the metal first. We don't change the name, and then we write the non-metal. If the metal has a different charge, it's possible. We have to explicitly state which charge it is, because there's 2 different iron chlorides. Here's iron chloride. That's iron 2 chloride, and then here's iron chloride. iron 3 chloride. And sometimes these are very different compounds, different colors, different properties. All right, so we have to indicate the charge on the on the transition metal if a transition metal is in it. In this case, sodium, there wasn't one, so we just say sodium. Okay, so NaCl is sodium chloride, not sodium chlorine. So we change the last part to ide. Okay, so we change that to IDE, sodium chloride. Aluminum phosphate. This is not aluminum phosphorus oxide. Okay, it's not aluminum phosphorus oxide. It's called aluminum phosphate. Phosphate is PO4. Okay, and I'll have to go through the ions in a second. Iron 2 chloride is FeCl2. And the reason it's 2 is because we know that charge on the iron is +2 because the chlorine has a -2. Right? If I have +2 and a -2 and I put them together, I get 0. The charge must be charge balanced, meaning that it must add up to 0. Okay, let's do something here before we get to naming acids. Let's go over our ions. All right, and I'm not going to do all of them, but I'm going to do many of them. So nitrate, NO3 with the -1 charge. Carbonate, phosphate, the -3 charge. Hydroxide, OH with the -1. That's hydroxide. Hydrogen carbonate. Okay, and I'll give you guys a list of these, okay? I'm just going to do them. So hydrogen carbonate. Sulfate is a very common one. Hydrogen sulfate with a -1. It's a -2, by the way, guys. Sorry, it's a -2. So 1 sulfur, 4 oxygens, and a -2. This is an ammonium ion. It's the only positive one. Notice these are all negative. Ammonium is probably the only positive one. Ammonium. Acetate is a C2H3O2. Sometimes it's written as CH3COO. Okay, so that's a COO. So that's acetate. It's a very common molecule. And I'm just doing these off the top of my head. Sulfate. We got a sulfite, which is an SO3. So sulfite. We got a phosphite with the -2. There's also hypochlorite, chlorite, perchlorate. This one's perchlorate. It's a -1. Perchlorate. I don't have these memorized off the top of my head. Perchlorate. Permanganate is MnO4 with the -1. So that's permanganate. C2 or CrO4 with a -2, I believe. I'm not positive, but CrO4 is called chromate. And then Cr2O7 with a -2 is called dichromate. And like I said, I'll get you guys a list, but these are our ions that we need to know. Okay. Let's see. I hit carbonate, phosphate, nitrate, ammonium, sulfate, phosphate. This is most of them. Okay. This is a chart on acids. I'm not going to go over it because we'll do this when we talk about acids. Okay. So this talks about if this is the name of the compound. So I'll do one example here. So we've got HNO3. So if I were to name that as a covalent compound, I would call it hydrogen nitrate. But since it's an acid, we have to name it in a special way. And so if this is going to end in 8, right? And then what we're going to do is we say hydro, and then ic acid. So this is going to be hydrogen nitrate, right? But if we make it an acid, it's going to be called nitric acid. Okay. Okay. So that's going to be nitric acid. This is going to be acetic acid. Take the acetate and change it to ic. This is going to be ethanoic acid. Okay. And we'll cover acids later. It's not a big deal. We'll talk about some of the main names for some of the acids as we see them. So that's not a big deal right now. All right, make sure you're practicing naming your compounds and writing your formulas. And we'll do these in class, okay? All right, I'll stop here. Thank you, guys. I know this was long. Thank you for your patience. All right.